Okay, ladies and gentlemen, we'll start the session at Rakuten, the Rakuten OpenStack platform and beyond. Please welcome Mr. Sasaki and Mr. Yoshigoe.
Thank you for your introduction, and thank you very much for coming our presentation. Well, so it's very great to see that so many people are here today. Well, today we'd like to talk about the OpenStack, how we use OpenStack in Rakuten. Well, so here's the agenda. So firstly, we'd like to we divide our talk into some main part. And firstly, we'd like to talk about OpenStack itself and its design in Rakuten. And then we'll focus on some of the customization we made and some of the impressions. And finally, we'd like to show you about our roadmap and our open source activities. Well, so before that, may I ask you some questions? So first, how many people are joining the morning session? The Tom, who is joining the OpenStack Foundation. Well, so many people joined that. So how many people use the OpenStack to deploy your application? Well, included using the public clouds, HP cloud or so forth and so forth. No one? Just excellent. Well, so how many people are deploying the OpenStack components itself by yourself? No one? No? Okay. Well, I mean, we'll just do that. So, well, how many people are joining the 2 days ago's lightning talk, which is Docker and Chef Puppet and OpenStack meetup? A few people. Well, so maybe you heard the Rakuten server-side operations, what's going on at that time. Well, so by the end of this presentation, you will understand the realistic and sustainable OpenStack system design for the big scale environment. Well, so if you have a plan to introduce the OpenStack to your company, well, this session become helpful even more. Well, I'm Kentaro Sasaki, and I've been storage architect since 2010 in Rakuten, and also I'm in charge of the OpenStack project. Well, usually I'm working on the object storage service, and also you can see my skill and expertise in this slide.
Hi, my name is Koichi Yoshigoe. I'm working on our private clouds, and especially for virtualization environment, which have 10,000 VMs, and my interest here. Please take food really even during the conversation. Thank you.
Thank you. So, well, OpenStack is 100% open source cloud management software, and it has been managed by the OpenStack Foundation since 2010. In 2010, the NASA's Nebula project became the NOVA, which is a compute service, and at the same time, the rack-based cloud files became Swift, which is an object storage service. And now the OpenStack has 10 core components as of April 2014. So, well, now there are some of the core components. It's difficult to explain what is OpenStack because there are so many projects. Basically, all components are independent of each other and communicate with the through the REST API. So the OpenStack market has kept growing, and around 20,000 people from the 104 countries have joined this project. So if you think about it, this is actually an amazing number. Well, so let me tell you why we chose OpenStack. Well, we chose OpenStack for these three reasons. So first one is the high quality REST API, because we want to change our development culture to an API first culture. So we need the REST API. So the second one is the abstract infrastructure. So because we want the extensibility so that we can have a multi-hypervisor environment. So the third one is to generalize and to use open source software to become the tech-driven company. So in doing so, we can keep utilizing the industry best practices. Well, so from next slide, we'd like to share about our current OpenStack system design in Rakuten. Well, in Rakuten, we have introduced these components to the Rakuten. The Keystone, which is authorization system, and Nova, which is compute service. Cinder is block storage, and Grounds is for the storage images, and Neutron, which is a networking service, and the dashboard. Horizon is the GUI dashboard. Well, so we are using the answers, which was released in April this year. This figure shows for our system design. Well, Rakuten's characteristic point is that running all of the nodes on VMware. Well, also just quickly introduce about that. Well, the one database server has just only one database to be easy to make size prediction. And in Rakuten, where the LDAP is our best authorization system, so we are using the LDAP for the Keystone's backend authorization. And also using the ZFS for the Grounds backend to store our OS images. And I know that the reference load balancer of the OpenStack is HA proxy, well, I think. But we are using the A10 for that instead of the HA proxy because it's more stable. Well, so consider both the active cluster and active Samba failover. We need around 20 servers at minimum, except for the Nova compute node. So the problem of this design is that this became the very complicated system. So, but I think it's not difficult to manage all of that. So this figure stacks each key factor component in layer. Well, so from the top, we are using the A10 load balancer and OpenStack, RabbitMQ for MQP, and MariaDB 10, GA for our database, and Splunk for our log analysis system. Well, and we are using the Ubuntu and the vSphere. And for storage, we are using Sleeper and Pure Storage for shared storage. So pros of this design is that we can keep the very, very high SLA, which is related to the hardware and hypervisor layer. And there are a few compute nodes, because when we use VMware, the normal compute node just communicate with only vCenter, so we can keep a few compute nodes to be managed. The concept of this design is that it becomes a very complex hardware design, and also far from the default standard design, because well, you know, the default hypervisor is KVM, so well, this design is far from that, I think, and of course it's very expensive. Next is about our region and the variability zone. Well, now we have 3 regions and 4 variability zones. And for common spaces, there are the keystone and horizon, which is authorization and the GUI dashboard. And region 1 has a sandbox, which is for the disposal of users. So we divide these spaces for our engineer, one by one. And region 2 has a development staging environment. And region 3 has a production environment. So, well, in Rakuten, we divide each regions by the networking. So, and in each regions, we provide the flavors, catalog specs to type the standard and high, which is defined by the IOPS, and also defines the region limitation to the 5,000 VMs. So if the VMs are running over the 5,000, we have a plan to make a new region. So 5,000 is one number of threshold. This figure shows the numerical environment. Well, so as you can see, the number of hypervisor is far fewer than the virtual machines. Well, so for example, when I check the number of VMs in Sandbox, 438 VMs are running on just only 2 hardware, 2 hypervisor. So because of that, this philosophy is that we can keep the very, very low power consumption, but the concept that it's become very high overcommitment. So we need to pay attention to some of the trouble, which is related to the hypervisor. And in all of the regions, the 80% of the VMs are CentOS, and 20% is Ubuntu, which is used for the Cloud Foundry class system. And in Keystone, we have 600 tenants, and we have 2,000 users. From this slide, we try to share about our redundancy concept. Here is the overview. So basically, we decided that one process is just running on one server that is except for the API node. And for API nodes, we are using Advanced Load Balancer, and active standby failover, we are using VMware HA. As you know, these API nodes, the Nova API, Sidan API, Neutron Server, and Grants API Registry, and also Keystone and Horizon. This process we using the load balancer for active failover cluster. as you know, we are using the A10 for that instead of the HA proxy. And I think there are no load balancer necessary for this process, then over conductor, over scheduler, and single scheduler. So we're just only running this process on the server one by one. So this figure stacks the redundancy of API nodes. So for the active cluster, we are using the A10 load balancer, and the active standby failover, we are using the VMware HA. And this figure shows our flow of the testing and deployment. Well, basically, we make some cookbooks or some patches, and for the developing OpenStack itself, we develop on our local PC with using the Docker, and then we push our code to our specific Git repository, and then we hooked it to the Jenkins and passing all of the tests, the chef server deploying all of our codes to each component on our system. Well, I think this flow is very similar with the other companies using the OpenStack. So when I attended the OpenStack Summit in May, I heard that there are many companies using the Chef for deploying the OpenStack itself. And also I think that the Docker has grown as popular as a container for the application engineers. So well, it is a very popular automation flow, I think. Well, so from next, go ahead, we'll explain the other part. So go ahead.
Thank you. Okay, from here, I will explain about some of our hacking parts and roadmaps and so on. Firstly, let's show our customization example in Rakuten. The concept is that base system is OpenStack native code, but there are some difficulties as you may expect. Okay. So first of all, customizing is scared. Maybe this is general in open source software, but OpenStack project is always changing and updated so often. So updating the system and applying patchy, and it's difficult if we customize the code internally. So we decided to avoid customization in Rakuten, but still we need to customize somehow. So if server engineer could change their operation style and current architecture, it would be very easy for us, but they wouldn't. So we need to customize some parts in OpenStack. So here are some examples we have been customized. Some of them are fixed by community already, and some others are merged by us into native OpenStack code, and some of them, like Neutron, is implemented just for our specific environment. So because customization is around vSphere environment in Rakuten, OpenStack with vSphere is most complicated things for us. So anyone, please help us. Yeah, please. And our vSphere environment is built with vSphere distributed switch, which is for network, and But in original Neutron, which is a network component in OpenStack, Neutron managing multiple distributed port groups cannot be used just single port group. So we customized, we implement some agent and ML2 driver for Neutron, and now VMs can have multiple distributed port groups with multiple VLAN. So this is just overview, so if you are interested in, please contact us later. So this is not customization of OpenStack code, but important for guest VMs. So in Rakuten, OS images are provided by platform side. So this is in order to standardize the OS layer among so many services in Rakuten, especially in Japan. But this is another story. So for such OS images and server engineers, we customized Cloud Init and config drive. So especially interesting point might be using LVM in Cloud Init and settings static IP and DNS registering DNS record from guest VMs. So using per instance module in Cloud Init, LVM expansion script is executed, and then setting static IP from Nova metadata because so we don't have DHCP on network, and register DNS record through internal in-house API. So after that, chef recipes will be cooked and server gets configured. So this vSphere and Cloud Init the overview of our customization at OpenStack project for the present. So now let me share our impressions of OpenStack project by our project members in Rakuten. So if you work on OpenStack, some of you would can agree on that, I think. So at first, we got so much difficulties. So member said. So architecture is complicated. So many components, at least 4, Keystone, Glance, Nova, Cinder are required, and database for each component also required, and message queue and network. So many components will be required. So maybe you will be confused. So also you need broader knowledge of some other stack like network, middleware, and hardware, storage, and there are tons of configurations. Network is complicated things, but I'd like to skip for this time. So maybe you can be smarter by using OpenStack, I hope. So other members said there are no best practice. So now many companies implement OpenStack environment in their own, but they are different from one by one. So many choices there. So excuse me. So the scale of number of VMs, network architecture, hypervisor, KVM is a de facto standard. So network topology, storage. So many stacks have so many choices. So I was surprised when I heard about other companies' OpenStack environment architecture. It sounded never differential for us at all. So their environment is totally different from ours. So there are other struggles. So many bugs we met in OpenStack. I hope this is fixed in Juno release, which is released this month. But yeah, most important thing for these bugs is reading source code. We studied. Yeah. But bugs are, yeah, it's natural. So reading source code. And at the last, yeah, this is the final boss for us, like King Koopa for Super Mario, Dr. Ram in Dragon Quest. So we met big changing on culture. So, you know, maybe you might know some of our operation style is legacy, but a little bit. So it's rather than, it's rather like a feature phone, Galapagos for our operation style. Rakuten operations need to change our mindset and the style, legacy style. But it's difficult to change people's mind. So maybe, yeah, our OpenStack project most important mission is changing our culture. So more than difficulties, OpenStack is so much fun. Yeah, yeah, yeah. Right? It is right?
Yeah, yeah.
And first, sorry. Excuse me. So much fun. Yeah, you know. So you can full stack skills through OpenStack, and yeah, not only knowledge of infrastructure but also software knowledge, networks, hardware, database. So many stacks you will. And so we are no longer system engineer, but also software engineer. So reading and writing source code and your broader technology range you will get through OpenStack. And secondly, you can be a pioneer in the world. OpenStack is being developed so faster, so that you can get cutting edge technology in daily work. And as I mentioned, there are no best practice, so you can develop your own best practice in each environment. So why don't you get involved in OpenStack project? Yeah, let's begin now. Anyone? Sorry. And here are more funds. So as the next one, you can contribute to worldwide projects through OpenStack. Bug fix, blueprint, code review, writing documentation, translating document to Japanese, any style you can contribute. So you will be one of the important part of the world. And developer can leave their names in codes, and company can make their presence bigger in internet industry. And then company can attract excellent engineers, operation style can be common, standardized, people can learn the operation quickly. So everybody will be happy through OpenStack. Why don't you begin? And furthermore, community activity is very fun. There are so many activities like knowledge sharing and regular workshops. And maybe you can be surprised when you join this activity. People there are, it's so eccentric. Yeah, yeah, some notes, and so much variety of people will be joined the committee, and like hardware vendor, software vendor, network vendor, and telecom companies, web companies like us, system integrators, and so salesperson, developers, so many varieties of people comes maybe, yeah, here too. So already chaos. Well, absolutely great opportunity to you to get many knowledge and many communications. So why don't you join these activities? So today, here is an announcement by Japan OpenStack user group. Hasegawa-san, please come here.
Hello everyone. My name is Akihiro Hasegawa, OpenStack ambassador and executive committee of the OpenStack Days Tokyo 2015. So today I will introduce you a little bit about our annual event. This is our third time event of one of the big OpenStack conference in Tokyo. And February 3 and February 4th, in the Grand Prince Hotel Takanawa, we have a 2 days event. At this event, more than 30 companies joined this, and there are Red Hat, HP, and there were some other big global OpenStack contributors also that joined this. And so, as they already mentioned, OpenStack, there are a lot of the components. It's pretty difficult to understand everything, and so this is a good opportunity for you to know such informations. And more, we are usually focusing on some of the business like the conference, but this year we are shifting to more the operators and the developers. If someone to starting the contribution to OpenStack, then we give you some training program named the Upstream Domain. And the Rakuten team is also helping this program for the mentor. And if someone who want to start the contribution, then let's join this event and attend this training program also. And this event will start in the registration the next month, November, mid of November maybe. And we have already opened the website. Please check it and join this event and enjoy the OpenStack world. Thank you very much.
Thank you. Okay, please register now. Next month. Sorry. Okay, continue to present some. So let's join the activities and events. So next part is our roadmap of OpenStack project. For future, we want to try more aggressively, and so here are some rough sketches of us. So at first, we'd like to implement more components of OpenStack in Rakuten. For example, currently, load balancer as a service and DNS as a service is in Rakuten implemented internally. And this accessibility is limited to some system engineers, and the function is not enough. So we'd like to switch them to Neutron LBS, which is OpenStack official project of load balancer as a service, and designate this is DNS as a service in OpenStack. And make API open to our developers more and more. So second one is expansion of region, our region. Currently we have 3 regions as Kentaro-san mentioned. We will soon make a new region along with another data center. And third one is most important things for Rakuten engineers. So migrating current 10,000 VMs into OpenStack inventory will be seriously required for Rakuten engineers. Maybe right? Okay, and so server engineers don't want to shut down their VMs, so that migration have to be done online. Fortunately, we already established the way to import VMs into OpenStack inventory. This is import rather than migration. And now we are testing this. And number 4 is hybrid cloud. So some services are already on public cloud like Azure, and so others will be. So in order to get more availability and scalability. So we are now considering abstract layer on each private cloud and public cloud. One is platform as a service in Rakuten. Is now us is running on Cloud Foundry version 1, and the PaaS team is now testing version 2. And for server instances in IaaS, we are now considering Terraform, which is developed by HashiCorp, to abstract infrastructure. So we hope this also help us to make infrastructure as a code. Maybe not Amazon, but Microsoft Azure is announced 2 days ago or so. Yeah. And the 5th one is auto-scaling. So the demand of auto-scaling is getting higher in Rakuten. The load of super sale and other events are much higher than usual. So we have to scale out the servers, but currently server engineers scale out such VMs by copying VMs one by one. And furthermore, this is performed by manually. So what the hell they are doing. But so auto-scaling in Rakuten is a bit high priority. So we'd like to test Hito components, which is orchestration component of OpenStack, and Sailmeter for monitoring, and so on. If any other better solution, please tell me and please tell us. Thank you. And furthermore, there are more challenges we want to fight, like much hypervisor and other components like Sahara, which is data streaming service, and Torov, which is database as a service, and others. And also we'd like to implement LeoFS with OpenStack, which is great, but LeoFS is open source object storage software developed by Rakuten. Maybe concurrent session the office is announced. And also Core OS and Docker and SDN we want to try from now on. So for next and at last, so let me share our OSS activities. OSS activity is the core of OpenStack, and of course other open source technology might be same. So this is open source strategy at Rakuten Global Operation section. This was established last April. So taking advantage of global developers and open source as it is. Basic policies follow mainstream and no forking, and build a plugin when function is required, and contribution back. Maybe this will truly help all of us and you in long term of open source activities. So for example of our activities, one of our members joined upstream training, Hasegawa mentioned, for OpenStack contribution. So this is training for contributing to OpenStack project at Atlanta this year. Our member Makigaki, he is not here today, but he joined this activity and he learned there about faster integration, real-world patch, and technical tools, and Git and some other workflows. So through these kind of activities, we Rakuten educates OpenStack contributors. So here is the number of code commitments into OpenStack by companies as of September. So there are a huge number of commits by major companies, and ours here, five commits to Juno. This is mainly by Makigaki, I mentioned, and I also committed into Nova by Bugfix. So number 5 is sounds small, but this is okay. This is very important for us. That Rakuten started commitment into OpenStack. So these codes are now released at Juno this month, and thank you for your cooperation, and congratulations for Juno release to everyone. And for last, one more topic from us. We will make our calls in GitHub as well. Yeah. So the contents will be chef cookbooks and bootstrap script of Cloud Init for OpenStack of ours, and so on. License will be GPL version 3, and we are planning this will be end of this year. So please keep it in your mind. Thank you. So this is last. Thank you for coming to our session today and hearing so long time. Thank you. And here is today's wrap up. So make long story short, we started OpenStack project, and why don't you start? So let's enjoy OpenStack project together. Thank you. And thank you for coming.
Thank you.
Okay, thank you, Mr. Yoshigoe-san and Mr. Sasaki-san.